Okay, we are on lecture 7, and we're going to be talking about the nomenclature of alkanes. We've already talked about functional groups, and now we're going to start looking at different chapters. So we will start with alkanes, naming alkanes. So we're going to look at alkanes and naming. I think the best way to do this is just to start with your POGL activity. So POGL activity 4 is on page 42. I'd also recommend looking at your slides and reading your book. Okay, so one of our goals here will be naming. We're going to try to name alkanes. And the nice thing about naming alkanes is it will teach you how to name other compounds. Okay, so Model 1, page 42. Okay, so look at that and see if you can answer those questions as I copy this down. You will need to start maybe making some index cards. You need to memorize this. It's a language. You need, in order to problem solve, you will need to know how to name compounds. And the best way to do that is just to start doing that. Taking a summer class doesn't leave you a lot of time, so it's going to be more intense. Okay, and then we're at the structure. I'm just going to do some of these as your line drawings. So propane, butane, pentane, hexane, heptane, octane, and I'll write that in there, octane. You see how you add the A and E? No, nane, 3, 4, 5, 6, 7, 8, 9, and then decane. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I won't ask you anything greater than decane, okay? So what do all the names have in common? They all end in ane, don't they? So because you're dealing with an alkane, okay, so the ending is going to determine what kind of functional group you have. What is unique about each of the compound names? Unique, the number of carbons, the prefix. Meth, ane, ethane means 2, propane is 3, butane is 4, pentane is 5, hexane is 6, heptane is 7, oct, like an octagon, is 8, nonane, non is 9, dec for 10, decane. Methane, ethane, prop, butane. What information does the prefix of the name provide? The number of carbons. In general, how is the prefix modified to name a straight chain alkane? It's modified depending on the number of carbons. Write in the names in the table for compounds 8, 9, and 10, which I have done. The prefix dodec means 12. Give the name of the corresponding alkane and draw that structure. So dodecane means 12. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. It's like drawing a Charlie Brown shirt, isn't it? Okay, now we're going to talk about branched. So we're going on to Model 2. Okay, Model 2. And we're looking at branched alkanes. And you can go ahead and try to read the questions and fill these in. You don't have to wait for me. All right, substituent. Compound name. Two-methylpropane. 2-methylbutane. 3-methylhexane. All right, so now we're on 3A. How many carbons are in the parent chain? Okay, so we're looking at entry A. Okay, so do you write down 3? There's 3 carbons in propane, the parent. Circle the parent chain in the structure shown. Okay, the parent chain is you find the longest carbon-carbon chain. Okay, that's always step number 1, and that's your parent chain. So here you have 1, 2, 3, and they want you to circle it. So that's your parent chain. And it happens to have 3 carbons. Circle the parent chain, underline the parent and the compound name. It's always at the end. So there's propane in the compound name. Okay, how many carbons are in the substituent? Substituent. Do you see that you have 1? Okay, so 1. Put a box around the substituent in the structure. So put a box around that substituent. And that's why, and these substituents end in YL. So that's methyl. That's how you know it's a substituent. Number of carbons in the, put a box around. Okay, so there's 1 carbon. Number of the carbons in the parent chain consecutively. So the step number 2, when you're doing the numbering, you want to give your substituents the lowest number. And that determines whether you go right to left or left to right. Okay? So here you would do, doesn't matter, 1, 2, 3. And if it doesn't matter, you just go, left to right, because that's what you're used to. Why is there a number 2 in front of the methyl in the name? Because it lets you know where that substituent's at. So if I tell you to come to Lexington, where I live, and come to Woodbine, drive, come see me. Come see me, I live on Woodbine, okay? Come see me, I live on propane. Well, if I'm a substituent, I'm a house, you're not going to know which house I am unless I tell you the number of carbon that I live on. So it's kind of like that, right? Okay, so for 2-methylpropane, what punctuation mark separates a number from a letter? These are your rules. So number 2, you number the substituent from left to right or right to left to give it the lowest number. Number 3, these are your rules. You put dashes. You always have dashes between numbers and letters. And you're going to learn that you put commas between letters. Between numbers. Between numbers. Okay? So those are the rules. So in your group, discuss what factors distinguish the parent from the substituent. It's the YL. Okay? So there's your YL. Okay, complete the table for C and D. All right, so what's your parent here? 1, 2, 3, 4. That's your longest chain, right? Okay, let's go ahead and circle it. And let's number it. So, let's just go ahead. 4 is butane. There's 4 carbons. You see the butane here? All right, and then your number, you want to go this time right to left. So you can give your substituent methyl, 1 carbon, the lowest number, 1, 2, 3, 4. If we went the other way, would have given a different number. Okay, so here we have pentane is our longest chain. Let's see if we can find that. 1, 2, 3, 4, 5. Okay, so we circle that. That's pentane. So we go ahead and write that down, pentane. And then our substituent is, we put a box around it, ethyl, which is 2 carbons. And 1, 2, 3, 4, 5. So it's 3-ethyl pentane. Okay, the next one, hexane. See if we can find the longest one. 1, 2, 3, 4, 5, 6. So let's go ahead and circle that long chain. And then let's number it. 1, 2, 3, 4, 5, 6. And that is a methyl, 1 carbon, 3 methyl. And the parent you have 6, and it's called hexane. So we were able to fill in the chart. That's number 4. 5A. For compound B in model 2, circle the number of carbons in the parent chain. We did that. Does your numbering scheme agree? Yes. Name the compound B is 2-methylbutane, not 3-methylbutane. What conclusions can be made by numbering substituents? Right here. You got to give the substituents the lowest numbering. Okay, number 6, for compound D. Circle the parent chain. Does the parent have 6 carbons? If not, circle a chain with 6 continuous carbons. The parent name for compound D is 3-methylhexane, not 2-ethylpentane. What conclusion can be made? You have to find the longest chain. And that's your parent chain. Devise a set of rules for naming substituents. So 1, you find the longest carbon-carbon chain, and then you name it with the parent. That's the first thing you do. Number 2, you have to number, and you give your substituents the lowest number, and then you put dashes between letters and numbers and commas between numbers. The commas between numbers is going to be your next model, which is model 3. And that title is multiple substituents. So if I told you to come to my house on Woodbine, but I told you, well, I own 3 houses and we're going to have a house party, and you're going to have like an appetizer at one house, a dessert at another house, I'd have to give you multiple house numbers. And that's kind of how we have with multiple substituents. All right, so model 3. multiple substituents. All right, 8A. For the compound of Model 3, what is the name of the parent chain? And that's the first thing you do. Hexane. What are the names of the substituents? You have 4-ethyl and 2-methyl. And I usually list them like that. Is there more than one substituent? Yes. You need to list them in alphabetical order. Okay, so what comes first? The E, right? E. So then it would be 4-ethyl -2-methyl hexane. And there's no space between methyl and hexane. Once your group has reached an agreement on a name of the compound in Model 3, check that the name has followed the following rules. Did you find the longest chain for the parent? Yes. Do you have the lowest possible numbers for your substituents? Yes. Are the substituents in alphabetical order? All right, so now it's your turn to do 8E. Draw the structure of 3-ethyl -2-methyl -4-propyl octane. Now, folks, you want to work backwards. So when you're drawing this, you want to start with octane. 1, 2, 3, 4, 5, 6, 7, 8. Okay? And then I always number. And when I do it, I just do left to right. 1, 2, 3, 4, 5, 6, 7, 8. And now we're going to put a propyl on 4. So 1, 2, 3. We're going to put a methyl on 2, 1. And then we can put an ethyl on 3, 1, 2. And there is 3-ethyl 2-methyl 4-propyl octane. All right, we have 2 more models to go. Model 4. Multiple identical substituents. So this is 2,3 dimethyl butane. That's A, and then we have compound B. All right, so 9A, for compound A and model A, how many carbons are in the parent chain? So 1, 2, 3, 4. 4. Are the circle the parent on structure A. Okay, so we did that. How many substituents are there in compound A? We have 2. Are the substituents identical? Yes, they're both methyl. So you got a methyl and a methyl. So you have a 2-methyl and you have a 3-methyl. In the compound name, what prefix is used? So you do have to memorize some prefixes again. Used to indicate the same substituent. Do you see it's di? So there's 2. There's 2 in common. Number the parent carbons. What are the substituent numbers? We did that, 2-methyl and 3-methyl. What punctuation is used to separate the names, the numbers in a name? A comma. All right, now we need to do compound B. How many carbons are in the parent chain? 1, 2, 3, 4, 5, 6, 7. So 7 is heptane. We'll go ahead and circle that. Okay, and then we want a number. 1, 2, 3, 4, 5, 6, 7. And we'll go from left to right because the substituent, you have a substituent here on the 2 and the 3, and that would give it lower numbers than if you started in the other one. So then you want to list these. You have 2-methyl, you have 3-methyl, and you have 6-methyl. All right, so number the parent from right to left, what are the substituent numbers? Number the parents from left to right, what are the substituent numbers? Okay, so you want to go, the substituent numbers are lower, because otherwise it would be 2-methyl, 6-methyl, and 7-methyl, and those would be higher numbers. All right, now we're at 10E. Provide the correct name. All right, well, you got to do 2, 3, 6, dash. Since there's 3, the prefix is tri, trimethyl heptane. Draw the structure. Okay, then they give you another one, 10F. Draw the structure for 3-ethyl 2, 4 dimethyl octane. And one of the goals you need to be able to do is to go from name to structure and structure to name. So we're going to start with octane. 1, 2, 3, 4, 5, 6, 7, 8. And the nice thing when you do your numbering, you can always do left to right. So 1, 2, 3, 4, 5, 6, 7, 8. Okay, then we have an ethyl on 3. 1, 2, 3. And we have methyls on 2 and methyls on 4. And that is your compound. All right, on to model 5. Okay, this is our last model for this POGL exercise, model 5. And you will have to memorize these, so add these to your index card, branch substituents. And these are the ones I will stick to. Branch substituents use the IUPAC or common names. Institute. For simplicity, the parent compounds below are not specified but drawn as rectangles. Only the substituent is named, and these names should come before the parent name. All right, so I will fill this in, and you can go ahead and try to answer some of your questions. We usually use common name, so this is really what you want to do is the common name. I don't know anybody that actually uses the IUPAC name. Okay, I'm not even going to worry about the IUPAC name. We're going to go straight to the common. Isopropyl, tert, butyl, isobutyl, sec-butyl. Okay, let's see what the questions are. For each of the compounds showed, look at the bond between the parent compound and the substituent. What number is always given to the carbon on the substituent? Don't worry about 11A. Starting with this point of attachment to the parent chain, find the longest continuous chain and circle it. Okay? Don't worry about B or C. Once the subparent is found, any substituent names are circled before or after. Okay, let's just look at, and I'm going to go ahead and just even, who cares? I'll show you. Okay, everybody uses just the common names here, so you do need to know that. And so look at problems 11, E, F, and we'll work 12. Oh, we do have another model. Okay, look at the common names given for each substituent. What does the subparent name refer to? Isopropyl. Why is propyl chosen? Okay, so this is propyl. It's a substituent, okay? They're coming off the parent chain, so that's why they all have the YL, okay? Because they're substituents. These are substituents. Isopropyl, propyl means 3 carbons. Okay, we have 1, 2, 3. And iso, I think of it as a Y. It looks like a Y. Okay, so when you do your skeletal, so if this is your parent, it looks like a 3-membered Y, isopropyl. Tert-butyl. Butyl means 4 carbons. Tert, I think of it as a cross. Okay, so you just got to get used to seeing this and recognizing it. So here's your parent, and you see a cross. You have 1, 2, 3, 4. Okay, isobutyl. Butyl is 4 carbons. Iso is a Y. So what does this look like? So here's your parent, and you can see you have 1, 2, 3, 4. 1, 2, 3, 4. There's your butyl, but it makes a Y. You see how it's a Y? So iso. And then sec, butyl, there's 4 carbons, and 1, 2, 3, 4. And it comes off of this carbon, and you'll see that this carbon, I'll put a star, that carbon is bonded to 2 other carbons, and so that's why it's considered secondary. Okay, and that's the sec. So you got to get used to seeing this. 1, 2, 3. You'll see it as the skeletal parent. So off the parent you have 1, 2, 3, 4. There's your butyl, and it's coming off of the secondary carbon there. And you see it does not make a Y. So you have 4 carbons. So you got 3 of these that have 4 carbons. They're tert-butyl, isobutyl, sec-butyl. And then the 3 carbon is just the isopropyl. So that's what they're talking about, 11F. Make any notes about the shape of the substituent that might help you remember these common names, because you're going to see these and you'll need to name them. And so you will need those. All right, now let's do 12. So we're just going to do the common name, and that's all you have to provide. So even in your additional problems, if it asks, you can just provide the common name. All right, so the first thing you want to do is find your longest chain. 1, 2, 3, 4, 5, 6, 7, 8. 8 is octane. 1, 2, 3, 4, 1, 2, 3. So obviously we're going to number 2, 3, 4, 5, 6, 7, 8. And let's go ahead and box in our substituents. Here is 3-ethyl, 4-methyl, and this is one of your branched. You see it has 3 carbons, isopropyl, okay, and that's 5. So 5 isopropyl. You have to do these in alphabetical order. So you would write 3-ethyl, -5-isopropyl, -4-methyl octane. And that's how you would name that. Okay, let's do 6. Model 6, it's called Cyclic Alkanes. And when you name cyclic alkanes, you need to add the prefix cyclo, okay, to the alkane. This is group 1, and this is group 2. And let's answer the questions. Questions number 13, 14, and 15. 13A. How many carbons are in the ring? 1, 2, 3, 4, 5, 6. How many carbons are in each group? 1, 2, 3, 3 carbons. In this group, 1 carbon. Which has more carbons? The ring group 1 or the ring? The ring has 6, so the ring has the most. And that becomes the parent. Okay, most of the time I'm only going to give you, like when I give you rings, the ring will be the parent. I don't know if you'll have that in sapling. Name the parent chain for the above compound. Remember to use cyclo in the ring of the parent name. So what's hexane? This would be cyclohexane is your parent. Name the substituents with Y. So this one here, isopropyl, and this one is methyl. Alright, so if you were to put that together, and let's do 14, I guess. In rings, one substituent will always be a carbon 1. Number of the carbons in the ring 1 through 6, starting with group 1 and continue so that group 2 has the lowest number. So remember how we did left to right or right to left when you did your parent chain? Well, in rings, you have to decide whether you're going clockwise or counterclockwise, and you have to always start with one of the substituents is number 1. So if we go clockwise, our next substituent becomes 3. If we did counterclockwise, 1, 2, 3, 4, 5, that would be 5. So we're going to go clockwise with our numbering, which gives this a 1 isopropyl and that a 3-methyl. Alright, so we are choosing clockwise. Do either of the two numbering schemes provide the lowest number? Clockwise. If both numbering schemes give the same numbers, choose the scheme that gives you the lowest number substituent that occurs earlier alphabetically. Alright, so basically your name then is 1 isopropyl -3-methyl cyclohexane. Now, some places wouldn't put the 1. Okay, the way I do your compounds is if you give me a name and I can draw it correctly, then it's correct. Okay? Okay, so for the following compounds, we're on 15. And we'll do this one, but it's not typically like I would give you. They're going to show you that you have 3 carbons in the ring, and then you have 1, 2, 3, 4 carbons in the parent. So the parent would be butane. And then you would name this as 1, 2, 3, 4, and then 1 would be propyl dash 2-methyl butane. And I think that might be a little bit more confusing, so but that's pretty much the acceptable. All right, so now you are ready for your additional problems. You have to make corrections of the name on question 16, page 49. You need to provide names for 17. You need to draw structures for 18.